Namaste. Today we are going to learn about some special parallelograms. First one is rhombus. This is a rhombus. It has all the properties of kite and a parallelogram. You know, in a kite, consecutive sides are equal. These two sides are having equal length. These two sides are having equal length. Here also, these two sides have same length. These two sides have same length. So it has the property of a kite. Also in a parallelogram, we know opposite sides are equal. Here also opposite sides are equal. Here this side and this side will be equal as in a parallelogram. These two sides will also be equal in a parallelogram. Also, opposite angles are equal. In a parallelogram, opposite angles are equal. So, here opposite angles are equal. This angle is equal to this angle. This angle equal to this angle. Now, considering the diagonals, we know in a parallelogram, diagonals bisect at the intersection point. Bisection means this length and this length will be equal. Also, this two lengths are equal. Like that, while we draw diagonals here, it also bisects each other. This is a diagonal, this is another diagonal. Now, these two lengths will be equal. These two lengths are also equal. Now, one more property is there for the rhombus. That is, they bisect at right angles. Here, all the angles will be 90 degree. But in parallelogram, it is not compulsory that it have right angles here. But in a rhombus, here in the bisection, it forms right angles. This is the extra property a rhombus is having other than a parallelogram. Rhombus have all the properties of kite and all the properties of parallelogram. Also an extra property, that is, it bisects at 90 degree. Now next property, let us prove the property. Diagonals of a rhombus are perpendicular bisectors of one another. I told you before. Perpendicular bisector means here all should be 90 degree. Now let us prove it. Let us name this first. Let this intersecting point be O. In a rhombus ABCD, we have diagonals AC and BD. Now we have to prove that OA equal to OC or OB equal to OD. That is, they bisect. Now next we have to prove that angle AOB, that is this angle AOB equal to 90 degree. Now BOC, that is this angle BOC, angle BOC equal to 90 degree. Next COD, that is this angle COD equal to 90 degree. Also angle AOD, that is this angle AOD equal to 90 degree. So this we have to prove. They bisect and bisection is forming right angles, that is 90 degrees. So we can say perpendicular bisectors. Perpendicular term shows here we have 90 degree. That is what perpendicular shows. So these diagonals are perpendicular bisector, means they bisect at 90 degrees. Also they bisect. Bisection means these length will be equal. So let us prove that with congruency of triangles. First, let us consider triangle AOD and triangle COD. These two triangles. In triangle AOD and triangle COD, in these two triangles, we have AO equal to CO. That is, these two lengths are equal. This length and this length are equal. Do you know the reason? This is a rhombus, but we know it satisfies all the properties of a parallelogram because rhombus is a parallelogram. So, in a parallelogram, I am writing like this, parallelogram, diagonals bisect. So, in a rhombus also, diagonals bisect. That is why AO equal to CO. Now, in these two triangles, this side is common side. So we can say OD equal to OD, common side. Now next, this side and this side will be equal. That is AD equal to CD. Do you know the reason? It satisfies all the properties of a kite also. In a kite, consecutive sides means adjacent sides which is lying nearby. So here this side's adjacent side is this. That is consecutive sides. In a kite, consecutive sides are equal. So we already learned that rhombus satisfy all the properties of a kite. So in a kite, consecutive sides are equal, means in a rhombus also consecutive sides are equal. So we got AO equal to CO, OD equal to OD, AD equal to CD. Now in these two triangles, all the sides are equal. So this is SSS congruency of triangles. Now we can say that this angle and this angle will be equal. That is angle, how will you name it? Angle AOD. AOD equal to angle COD. It shows this angle COD. Reason is CPCT, that is corresponding part of congruent triangles. So these two angles are equal. To prove it is 90 degrees, we have to consider this part. You can see it is a line segment here and a line is falling here like this. And it forms a linear pair. So this angle and this angle will be linear pairs. We know linear pair means their sum is 180. That is angle AOD plus angle COD. That is both angles. Sum is 180. Reason is linear pair. If these two are equal length, let this be x. We don't know the correct value. So let us put x plus this also x. If this is x, this is also x. It is proved. Angle AOD equal to angle COD. We have already proved it. CPCT. So these two measurements are x. X plus x equal to 180, linear pair. Now x plus x, what is x plus x? 2x is equal to 180. X is equal to 180 by 2. 180 division 2 is x is equal to 90. That means here this angle is 90 degree. This angle also 90 degree. So we proved that it is a perpendicular bisector. That was the property what we have to prove. That is diagonals of a rhombus are perpendicular bisectors of one another. Next is a rectangle. It is a parallelogram. Rectangle is a parallelogram and properties are, parallelogram properties we know. Opposite sides are equal. Opposite angles are equal. And we know in a rectangle here all are 90 degrees. Next property of a rectangle is diagonals of a rectangle are of equal length. In a parallelogram, it is not given that diagonals are of equal length. That is this length. This is one diagonal and this is another diagonal of same parallelogram. It is not compulsory to be equal in a parallelogram, but in a rectangle it is equal. That is this diagonal and this diagonal will be equal. That we have to prove now. We already know that it is a parallelogram. With that we are proving diagonals also are equal in a rectangle. That is the extra property for rectangle other than parallelogram. Also here all are 90 degrees. Let us draw the diagonals in this rectangle. We will name the rectangle A, B, C, D. Now to prove diagonals are equal, we will split this rectangle to two triangles. That is triangle ABC. ABC is like this. ABC. Can you see ABC? ABC. This triangle. Now We are considering the other triangle ABD. Triangle ABD. How is that triangle? ABD. Like this. ABD. Okay. This is ABC and this is ABD. We will prove the congruency. Here, in these two triangles, AB and AB are common. They are lying at the same line segment. Can you see it? AB equal to AB. Common. Next, BC equal to AD. Here, this is BC and this is AD. Consider this. This is BC and this is AD. We know BC equal to AD because we can say it is a parallelogram too. In that, opposite sides are equal. Opposite sides length are equal. Angle A equal to angle A, that is this, and angle B. This angle and this angle are equal. The reason is all are 90 degree. In a rectangle we know all the angles are 90 degree. So what is the congruency here? Side, angle, side. Side, angle, side. Angle lies between two sides equality, right? That is why side, angle, side. SAS congruency. These two triangles are congruent. So that we can say this length and this length will be equal. That is AC equal to DB. CP, CT. Correspondent part of congruent triangle. If these two lengths are equal, that means which is this length? DB, right? DB means this length is equal to AC. AC is this length. Both are the diagonals. So we got in a rectangle, diagonals are equal length. This diagonal and this diagonal have same length. But in a rectangle, it is not compulsory to have here 90 degrees. That is bisecting at right angles or perpendicular bisectors. Only thing is that they bisect each other. Here the lengths will be equal because it is also a parallelogram. But it is not a rhombus. So we can say here it is not 90 degrees. Now coming to the next figure. Next is square. Let us name this A, B, C, D. Now the diagonals are BD and AC. Now square have property of a parallelogram because square is a parallelogram. If it is a parallelogram, we can say opposite sides are equal. AB equal to DC and AD equal to BC as a parallelogram. Also angle A equal to angle C. Opposite angles are equal. And angle B equal to angle D. As a parallelogram, we can say opposite angles are equal. Also, it bisects, that is diagonals bisect. Here O, then AO equal to CO. Also, BO equal to DO. Here the length are equal because in a parallelogram, diagonals bisect. Now the square have all the properties of a rectangle too. As a rectangle, we can say rectangle is a parallelogram, so this all properties satisfy as a rectangle too. Now extra property is that all the angles are 90 degree. So that is the extra property other than the parallelogram. Now the next. So rhombus means rhombus have all the properties of a kite and a parallelogram. So as a kite we can say adjacent sides, that is consecutive sides are equal. CD equal to BC and AD equal to AB. Also it is a parallelogram, that means their opposite sides are also equal. So comparing kite property and parallelogram property, we can say CD equal to BC, AD equal to BC, AB equal to DC, AD equal to AB. That is all the sides are equal. That is opposite sides are equal, adjacent sides are equal. That means square have all the sides equal. Now considering the diagonals, we already got it bisects. Now this is a rhombus too, so we can say it bisects at right angles, perpendicular bisectors. That is, here it is 90 degree, 90 degree, 90 degree, 90 degree. Also here it is 90 degree, 90 degree, 90 degree, 90 degree. These are all the properties. Here it is 90 degree because it satisfies the properties of a rectangle. And here it is 90 degree because it satisfies the property of a rhombus. So these are all the properties of a square. It satisfies properties of parallelogram, rectangle and a rhombus. And we know rhombus satisfy properties of a kite and a parallelogram. So we can say square satisfies properties of kite too. Also in a rectangle we studied that diagonals are equal length. That is, diagonals are AC. AC is a diagonal and next diagonal is BD. AC equal to BD. Diagonals are equal. So it is also a property of square. Now if it is asked to prove any of these properties for a square, we have already proved in rhombus, parallelogram and rectangle. You can write the same steps in the square. That is, if you want to consider this property, then you will consider the triangles like this. We have already done in the rectangle. If you want to prove that opposite sides are equal, then you will consider triangle ABC, this triangle, and same CDA, that is upper triangle, as in parallelogram. We have already proved it in the parallelogram. So consider it to prove these two sides are equal. This we consider as in the rectangle, these diagonals are equal. Now if you are asked to find bisection of diagonals, that is, bisection of diagonal means in a square, bisection, this length and this length are equal, or this length and this length are equal. Diagonals bisect each other. If you want to prove that, consider this upper triangle COD and AOB, this triangle and this triangle, as in the parallelogram. We have already done that. Now next, if you are asked to find perpendicular bisectors, that is, these two measures are 90 degree, then you will consider the triangles, these two triangles, that is this triangle and this triangle, as in the rhombus. Then you can get it bisects at 90 degrees. Now these are the properties of a square. This we did in the rectangle. It is already proved. This we done in the parallelogram. This also we done with the parallelogram. And this we done with the rhombus. So if it is asked in the square to find these properties, you can copy from those steps. You will get the same answer. Next, exercise 3.4. State whether true or false. All rectangles are squares. It is false because all squares are rectangles. But all rectangles are not square. What is the reason? In a rectangle, only opposite sides are equal. But in a square, all sides are equal. A square is a rectangle. It satisfies the property because opposite sides are equal. But in a square, all sides are also equal. But it doesn't satisfy in rectangle. So, square is a rectangle, but rectangle is not a square. All rhombuses are parallelograms. All rhombus. Yes, all rhombus are parallelogram because it satisfies all the properties of parallelogram, but all parallelograms are not rhombus because in a parallelogram consecutive sides are not equal.
But in a rhombus, consecutive sides are equal, also opposite sides are equal.
Next, all squares are rhombus and also rectangles. Yes, it is true. All squares are rhombus and all squares are rectangle too because squares satisfy all the properties of a rhombus and a rectangle. Next, all squares are not parallelograms. False. All squares are parallelograms also because it satisfies all the properties of a parallelogram. So, it is false statement. Statement is all squares are not parallelograms. It is false. All squares are parallelograms. Next, all kites are rhombus. No, kite is like this. It is not a rhombus. In rhombus, all the sides are equal, but in a kite, only adjacent sides, that is consecutive sides, are equal. Next, all rhombus are kite. Yes, all rhombus are kite because in that consecutive sides are equal. The property of a kite is consecutive sides are equal. Yes, it is equal in rhombus. Here these two sides are equal. Here also these two sides are equal. Only difference is that in this all the measurements are equal. Here these two measurements are equal and this will be another value. Next, all parallelograms are trapezium. Yes, in a trapezium, the condition was either one of the side be parallel. In a parallelogram, yes, it is parallel. So, we can say all the parallelograms are trapezium. Next, all squares are trapezium. Yes, in a square, any of the pair is parallel. In a trapezium, it is the only condition. At least one pair should be parallel. Yes, in a square, at least one pair is parallel. So, it is a trapezium too. Next, identify all the quadrilaterals that have four sides of equal length. Which are the quadrilaterals? Rhombus and square have all the four sides equal. For right angles, it is again square and rectangle. Here all the sides are 90 degrees. Next, explain how a square is a quadrilateral. Square is a quadrilateral because it has four sides. Four-sided figure is named as quadrilateral. Now, explain how a square is a parallelogram. A square is a parallelogram because it satisfies all the properties of a parallelogram. That is, opposite sides are equal, opposite angles are equal, diagonals bisect each other, and opposite sides are parallel too. So, we can say square is a parallelogram. Now, explain how a square is a rhombus. Because it satisfies all the properties of rhombus. That is, all the sides have equal length and it bisects the diagonals at 90 degrees. That is perpendicular bisectors here. Here will be 90 degrees. So it satisfies all the properties of rhombus. So square is a rhombus. Explain how a square is a rectangle. A rectangle, opposite sides are equal. In a square also opposite sides are equal. All the angles are 90 degree. In a square also all the angles are 90 degree. And diagonals are of equal length. This diagonal and this diagonal have equal length. Not about bisection, it is equal length. This length and this length will be equal. Yes, in a square also diagonals are equal length. Name the quadrilaterals whose diagonals bisect each other. Which all quadrilaterals diagonals bisect each other? Parallelogram, rhombus, square and rectangle. In these four quadrilaterals, diagonals bisect each other. Here the length will be equal. Next, name the quadrilaterals whose diagonals are perpendicular bisector. Perpendicular bisector quadrilaterals we have only two, that is rhombus and square. Here the angles are 90, here also the angles are 90. Next, name the quadrilaterals whose diagonals are equal. Equal length, this and this length equal only in rectangle and square. This rectangle and square have diagonals of equal length.
Explain why a rectangle is a convex quadrilateral. The property of a convex quadrilateral is diagonals are in the interior. You can see from the figure ABCD rectangle, both diagonals are in the interior. So it is a convex quadrilateral.
Next question, ABC is a right angle triangle. That means here it is 90 degree. ABC is a right angle triangle means angle B is 90 degree. And O is the midpoint of the side opposite to right angle. This is the midpoint of AC. So here the length will be equal. It is given in the question because it is the midpoint. Midpoint divides a line to two equal parts. Explain why O is equidistant from A, B and C. We have to prove that why AO equal to BO equal to CO, or why all these lengths are equal. AO equal to CO equal to BO. The dotted lines are drawn additionally to help you. They have given a hint to prove this AO equal to CO equal to BO. We extended and draw a figure like this. Now, from this figure, we have AD is parallel to BC, BC parallel lines, and AB is parallel to DC. So we can say this is a parallelogram, and here it is 90 degree. Angle B equal to 90 degree means in a parallelogram angle D is also 90 degree, opposite angles. And we know in a parallel line, if a transversal falls like this, if this is 90, this will also be 90 because it is consecutive interior angle and its sum will be 90. So this whole angle is 90. That is angle A equal to 90. Then if angle A equal to 90, we know this is a parallelogram, then angle C is also 90. So we got like this. And we got in this figure, all the angles are 90 and opposite sides are parallel. And which is that quadrilateral? So we can conclude that ABCD is a rectangle. It is a rectangle. So we have a property for rectangle, that is their diagonals length are equal. AC will be equal to BD. AC equal to BD. These are the diagonals. AC is one diagonal, BD is another diagonal. Their length are equal. We know AC means AO plus CO. Both this length added together we will get AC. So AC we can split as AO plus CO. AO plus CO is AC. Now next BD we can write as BO plus DO. We will get the length together. So BD is BO plus DO. Now we got like this. In a rectangle we know these two lengths AO and CO will be equal because it is bisectors in a rectangle. Diagonal is a bisector also. So the length AO equal to CO and BO, this length and this length will be equal because it is also bisector of diagonal. BO equal to DO. And we have to prove that AO equal to CO equal to BO. We got AO equal to CO equal to BO. This is enough for us in the question. AO equal to CO equal to BO. Reason is the diagonals of a rectangle bisects each other. So we can say AO equal to CO equal to BO. Diagonals bisect. That is the reason. So we can conclude from the question, O is equidistant from A, B and C. Equidistant means this lengths are equal. That is AO equal to CO equal to BO.